Okay, let's get started. So, good afternoon, everybody. Welcome to this session about technical debt management with CABL and SonarQube. So, my name is Gilles Quéré. So, just a few words about me. Somebody already asked me how do we pronounce my name. So, this is Gilles Quéré. This is French. So, you can just remove half the letters. So, no final S, no double R, no remove. If you don't know how to read phonetics, I don't know how to read phonetics too, so I just copy-pasted it. So, you may have understood it. I'm not a native English speaker. I'm French, so you will have to deal with my accent for the next 45 minutes. I started Riverside Software in 2007, so yes, almost 13 years ago. And the focus of the company always have been work on the continuous integration and on source code analysis. So, continuous integration, I don't know how many of you have been using, have a continuous integration cycle in their company. I've been working on PCT, which is an add-on to Ant in order to enforce or to do build automation for ABL code. So this has been included in Progress since 11.7 something. 4.3, I don't know, I don't remember exactly. And so it became a de facto standard for build automation. And so the next step after continuous integration is the ability to continuously analyze your source code and verify that it matches the quality standards of your company. So just a quick question. How many of you are developers, so working on a daily basis on code versus managers or managing developers? So developers, managers, okay, good. So if you're a developer, it's easy to understand what bad code means. Having very low quality code, you know how it can be a pain in your daily work. However, when you have to explain to your manager that this code is a bad one, and so I'm spending a lot more time than you would expect me to spend on adding a new feature or on fixing bugs. It's very hard to explain that to your manager. So this is why Ward Cunningham, so this guy, and he's a guy behind the concept of wiki. So I'm sure everybody is using Wikipedia. So this concept of wiki was invented by Ward Cunningham. And so he also coined this term of technical debt. And that was for developers to explain to their managers what it is to have a low quality code base. So this means that it's just a metaphor around the time it takes to work with low quality code. So if you have a huge technical debt, whenever you're going to work on your code, whenever you want to fix a bug or to add a new feature, you will spend more time because you will first have to do some refactoring. There won't be any unit tests, so you won't know if you are breaking something when you add a new feature. And so this adds up, and you just pay interest to this debt. So you just spend more time, and this is exactly the interest that you are paying to this debt. And you can do something with this technical debt. So you can pay it on the principal. So this means you just refactor code, you add some comment, you clean up code, you add a unit test, and so you paid on the principal, reduce your technical debt, and then anybody in the future that will work on your code base, they will spend less time because they are unit tests. They will be able to know that you add something and it gets broken immediately before going into production, before getting a report from your customer that something has been broken. So you can still continue working on quick and dirty features. You just pile onto the existing technical debt. You just have to know that if you are doing something quickly, you will add some more technical debt and you will pay even more interest in the future. So you can do whatever you want with your technical debt. There might be a high technical debt. You just have to know as a manager that you are going to pay interest to this debt. If you are a financial company, I just have to tell you that there is no stock market for technical debt. You won't be able to make any money out of your huge debt. Sorry. I'm sure some companies would be extremely happy to have this kind of market. So, just as a developer, here is something you might have encountered. So you have some code, you don't know what it does, it just works, but nobody knows how, why it is working this way. So this is just this concept of what we usually call a code smell. You can see something in the code, something you wouldn't want to see. There might not be a bug, that might not be a vulnerability. It's just something that you don't want to see in your code base, or something that you are not able to explain. So if you have to work on a bug fix, or if you have to add a new feature, as I've said previously, there are multiple options. You can start by understanding what's happening in the code. So once again, you pay interest to the debt because you have to spend time, or you can just try to add this new feature and ship it into production and wait until the customer reports something, probably because you have broken it. So this concept of technical debt also has to be quantified. So this means that you have to tell your manager, I would like to provide a metric to tell you if our code is quite bad or really bad. And in order to do that, it's possible we are developers, so one idea is just to go at the door of the code review team and just wait, listen to the number of what the F word you're hearing there. However, we are all developers, so this is not something you could put the number in a database and in order to do some trends and so on, but we are developers, so we want to keep track of that. We want to keep trends of the technical debt. So you need tools in order to do that, in order to trap some of the common mistakes, such as code readability, so code which is difficult to understand, or does it match the coding standards? Are there some bugs or potential bugs? Are there some vulnerabilities? So if you are working with a website, for example, you have to make sure that the code is secure enough, and just do a computation with a number of issues and the time it will take to fix everything. And that will be this technical debt. That will be expressed as usually as a number of days to fix everything. So you will have one number and you will pay interest to this number. So what I'm going to show you is SonarQube. How many of you know the name SonarQube or already work with the product? Wow, impressive. Okay, so SonarQube is a product which is written by a company in Switzerland. They are based in Geneva in Switzerland, and it's an open source code quality management platform. So they went from aggregating some metrics from various tools for the Java language into a database in order to compute this technical debt. And so they went from there to a huge platform in order to huge and generic platform for code quality management, meaning that it's there to provide the infrastructure to execute rules on any language and to make it easily accessible to the developers and to the managers. So the product is there since 2008, 9, 10 approximately, so almost 10 years. It's an open source platform, and then it's extensible. So there are also some commercial editions for this product, especially if you want to work with some languages. So if you want to work with CABL, for example, you will have to pay a lot of money because SonarSource just expects that you are a bank, so you will pay a lot of money to analyze CABL. However, there are many languages which are available under the open source license. So if you are working with Java, JavaScript, for example, for the most common languages, this is available under the open source license. There are approximately 20 languages which are available, so the most common ones are available. So what I've said is that SonarQube, this product want to make it accessible to anybody to the numbers of for the technical depth. So this is the dashboard that you can have access to when you analyze one product. So this is a main page when you go into the web UI where you can see exactly what has been detected during the code analysis. So here you can see the number of bugs on your code base. So bug, this is something which could lead to a crash, to a crash in production. This can also detect some vulnerabilities. So as I've said previously, if you have a web application, you have to make sure that everything is secured enough so that you don't get hackers going onto your website and getting unauthorized information. Also, code smells. Anything which is absolutely everything that you wouldn't want to see. Yes. So this could be just uncommented code or huge chunks of legacy code using legacy statements. So anything you don't want to see in your code base. There are many different types of code smells. And here, the technical depth by itself, which is expressed here as a number of days, this is computed by just adding the number of issues, and for each issue there is a remediation cost, and so you just multiply each remediation cost with the number of issues, and you end up with a number of days in order to fix every single issue of your application. You also have access to the code coverage. Code coverage is a very important metric if you have unit tests, because you want to know when developers introduce unit tests in development, you want to double check that what they are testing is some new code, or if they are just adding code which are testing parts which have already been tested. So using code coverage, you want to monitor the increase of the number of lines of code which are being really tested during the unit test or integration test. It can also monitor code duplication. Code duplication is very, very bad. This is just developers doing Control-C, Control-V, or Command-C, Command-V. As soon as you do that, if you find an issue in the first version, that will be fixed in one location, but then you will have to repeat the same process in any other location where this has been copy-pasted. And usually this is never done. You fix the issue in one location, and this is not fixed in any other location. So you end up with almost twice the number of issues. And copy-paste, in many cases, you will find code blocks which are pasted 20, 30, or 50 times. This is exactly the same code, and the only thing that you have to do is to do some refactoring so that you only write code once, and you reuse procedures or include files, and so when you fix the issue, you do it in a single location, and that will be fixed for everybody. So this is what happens? Because the previous slide was on a project with, I don't remember, but probably 1,000 lines of code. So nobody has 1,000 lines of code. I'm sure anybody has a code base ranging from a few hundred thousands to 10 millions, 15 millions. That's the usual metric. So here on this project, 2 million lines of code. And technical depth, the number is not written there, but 100,000 code smells being found, 10,000 bugs, 2 vulnerabilities just because there are no vulnerability scanning on this project. So you end up with a huge number of issues. So what are you going to do? So when you show that to your manager, to the boss, what do you say? What do you tell him? Do you say, oh, we can just start a new project, we are going to have a few developers, we will pay them for 4 years, and they're going to fix every single issue in the code base. Tell that to your manager. That will be funny, probably. So you just have to assume that your technical depth is there. It is present. Your project is running in production. Your customers are using your product, so it works. You know that there are some issues. You know that there are code smells. You just have to live with them, and you have to make the product better. And in order to do that, we can use this kind of image. So this is your code base, and you have water everywhere. So this is the existing issues on your code base. And what is the first thing that you want to do? Do you want to mop the floor, meaning do you want to fix every single issue in your code base, or wouldn't it be better to first start by having a look at the leak? So here there is a leak coming from the ceiling, so you just have a look at exactly where this is coming from and act in consequence and say, I will just close the tap so that there won't be any more issues in the code. And the idea of that is to, in a development lifecycle, just to make sure that any new code which is written in your application doesn't introduce new issues, that you don't add some technical depth onto the existing one. So you can live, you will have to live with the existing technical depth. You will just want to improve the number over time, but the first thing that you want to do is not to introduce any new issue in the code base. And this is where SonarQube is very good, because by doing a link between the source code repository, especially when working with Git, for example, SonarQube is able to monitor any new line of code which has been introduced in a feature branch and say, I've detected some new issues on those lines, and this is exactly what has to be fixed before merging onto the main development line. So whenever you open a feature branch in Git, you want to have a code review, and SonarQube can be there by providing information to the code reviewer and tell them, oh, you added a new procedure or an internal procedure into an existing .p, for example, and you added a few blocker issue right here. So this is new code, so fix it before you can merge your code onto the main development line. So, and this is code which is currently being worked on by the developer, so it's very easy to fix it if you have the information as quickly as possible, because you are working on the code directly, and it's extremely easy to say, oh yes, I'm working, so if I modify this statement, I know exactly what I am doing. I'm working on this code. So as opposed to fix issues on code base which hasn't been touched in the last 10 years, for example, where when you want to modify this kind of code, you have to really think about it, and it just takes a lot of time to fix the issues there. So SonarQube provides this concept of leak period. So by just monitoring the feature branches and providing the information to the code reviewers about there are new issues, or also there is new technical depth, or there is not enough code coverage in the code that you are working on. So please improve those numbers, and over time, your product will just get better and better. So, and you will just reduce the technical debt over time, and it's a long-term project, and your manager will be okay if you work this way. You don't have to prevent your developers from working correctly on the project. You just have to make sure that new code is written correctly, nothing more. So now onto CABL. So CABL is a plugin which is developed by Riverside Software. So it's an open source plugin for SonarQube, which includes a preprocessor and parser, the ability to report some metrics onto the SonarQube platform. It also detects code duplication for ABL code with more than just detecting the lines of code, because, for example, it's able to detect comments, for example. It's also able to detect abbreviated keywords. So it will detect code duplication, even if the code looks like it's completely different, just because there are comments in the middle of everything, where it could be even be duplicated code. It's also able to import the ABL warnings, so Progress is doing, to my mind, a good job at introducing compiler warnings since 11.7. So instead of having them available only during the build, it's possible to report them directly onto the SonarQube platform so that you can see the trend on the number of warnings and have a view. Usually the warning, nobody pay attention to those warnings. So there you can have a central location where you can have access to them. It does xref parsing, code highlighting, and then there is an extensible rules engine. Because when you analyze ABL source code, what the parser does is to transform any procedure or class into a syntax tree. So you have a huge tree of every statement, every option of the statement, and then you want to execute rules in order to detect bad patterns. So you work on the tree and say, when I see this kind of statement followed by this one, and then there is another class with using this method or whatever, we are free to do whatever you want, then you browse through the tree and you report an issue onto the SonarQube platform. So it's extensible, meaning that it's possible using the open source version to write your own rules in order to enforce your own quality standards. Or if you have an internal framework where you want to tell anybody not to use this procedure anymore, not to use this internal method anymore, you can create a rule for that. And you can do that using the open source version. If you don't want to spend any time working on the rules, Riverside provides a set of commercial rules where that will detect potential bugs, coding standards, and so on. So there are approximately 80 rules which are available out of the box, and also the code coverage functionality, which is only available in the commercial edition. The way we wanted to have the product done is by triggering the code analysis within your continuous integration cycle. So if you already have a continuous integration environment where you can automatically build your code with PCT, then it's extremely easy to trigger SonarQube. You just have to add a single line in your build file and you will be done. You just configure the ProPath, database connection, and execute the SonarQube command, and that will be done. CABL is also SonarLint, which allows you to execute on-the-fly code analysis directly within PDSOE, meaning that what I've shown previously, you have access to a web user interface where you can get the metrics. But this means that you have to wait until your continuous integration cycle triggers a build onto the build server, executes the code analysis, and reports it onto SonarQube. It's usually not really long, but it can be up to 1 hour. Isn't it even better if you can have some reports directly here when you code, directly within PDSOE? So it's possible to do that directly in PDSOE. You save a file, and all the rules will be executed, so you have an immediate report of what's wrong in your code. So I'm going to have a quick demo. So let me, any question at this stage? No? Okay, so. Let me. Here it is. So this is a main page, the main dashboard for a test project. Is it large enough, or do you want me to increase the font size? I can make it larger. It's good? Okay. So here, this is a test project, so it's kind of stupid code. However, we will go directly, for example, onto the code smells. So it's possible to drill down onto the code. So the entire code base is being analyzed. The source code is pushed onto the SonarQube server. And this means that you can drill down into the code and see exactly what is detected, or what is the line number, and you can see exactly what's happening, what has been detected. So here, for example, the first issue is this a table with 5 indexes has been detected. So it's possible to go directly into the source code, and CABL is also able to analyze DF files. So you can analyze your database schema and see that I just want, for example, to enforce some naming standards for the tables or for the fields. It's possible to write this kind of rule in order to enforce naming conventions, for example. And you can report an issue here. So if you want to set a threshold, for example, I've already seen tables with 50 or 60 indexes. So this just slow down any record creation or update or deletion, because you have to update a lot of indexes. So you can set a threshold and say, if there are more than this number of indexes, and this number can be configured directly in the UI here. I've set a threshold at 5. However, you could set the threshold at any value. You could say in my project or in my legacy project, I set a threshold at 20, because there are so many tables where there are lots of indexes. But on another project, I will define a different quality profile and say, I would like to set the threshold at a different value, just because it's a different kind of project. So here, this can be detected in multiple locations. We can also, for example, if we have a look at some blocker issue, any issue can be defined by a severity. So here's some blocker issue, and we can find there is one table in Sports 2000 where there are absolutely no indexes, which is usually a very bad idea in a real application. You need at least one primary index on your table. So detecting that somebody added a new table in your database without an index can be trapped extremely quickly. As soon as a developer commits the code in the repository, everybody will know that, oh, there is no index, you forgot to add it, or maybe you messed up in the dump file, you forgot to add the index. Fix it and make sure that you don't ship this version without an index onto the customer. So here for blocker issue, here, for example, a very simple rule which is working on xref. So we just read the content of the xref and say, oh, there is a sort access and hood index on a specific temp table. So there might be a potential problem in performance. It will probably, if the table is extremely large, it might take a lot of time just to browse through all the records. We can go, for example, on to critical ones. So here, a very usual one is unused variables. So you define something in your code and you don't do anything with variables. So this is just a waste of memory because the variable has to be created. Just text memory. It's also not very good for code readability because usually you have hundreds of lines, and there are so many code bases where there are defined variable x1, x2, x3, and this is repeated a lot of time. And in many cases, none of those variables are being used. So you can keep track of, is this variable being assigned or read or nothing? So this is here an example of a compiler warning, so something which has been introduced in 11.7. So the warning, this is the require field qualifiers. So you access a table, the customer table, but you didn't set the table name in front of the field. So if you have a variable which is also named custom, you don't know exactly which value, from where the value will come from. Does it come from the field, from the table, or from the variable? Or you can detect deprecated keywords, so work table, you should now use temp tables, for example. That's better usage. So in order to modernize your application, you can just have a look at this kind of statement is being used in 1,000 times or 1 million times, and how long does it take to fix everything in order to modernize the application, so, and keep trends of that. So for example, for code coverage, we can see here, for example, we can see exactly line by line if one line has been executed or not been executed during the unit test. So here there is a red or green marker next to each line, so we recognize exactly is this an executable line, and has it been executed or not during the unit test. And this is exactly how the computation is being done. We just do the math to compute the code coverage and say here, this has been executed, this internal procedure here, procedure foo, has not been executed, and you just want to keep this number growing over time. And so with that, you can also double check that when you write new unit tests, just to verify that you are testing something new, or do you test something which has already been tested in a different location? So if you add new tests and you don't add code coverage, it's pointless. You can remove your unit test. It doesn't test anything, or something which has already been tested at least. We can also do that for, we can also test code duplication. So here, this is a very simple example where, let me find another example that will be much better. Project, I will go to PCT. PCT is being analyzed, and yesterday I found out that in code duplication, there is some code duplication. It's bad. So yes, I'm running SonarQube on my own code, and there are still issues. So yes, I have to live with the technical debt of PCT especially. So here, for example, here on the main compilation procedure, there is some duplicated code, and this is available, if I remember correctly. No, that was there. Yeah, for example, this block of code here, this gray line, I know that from line number 789 to 814, this is duplicated in another procedure, and I can go directly at the line number. It will display exactly where any code block is being duplicated. So you know exactly what to fix. And that was line number 180. So here we have exactly this function file exists. So there is an implementation in both locations. So if I fix it in the main compilation procedure, that won't be fixed in the other procedure. So I end up with somebody will report an issue, and I'm sure that a bit later somebody else will report the issue on the other location. So if that was refactored correctly, I would have been able to fix the issue only once, and that would have fixed the problem everywhere. So there are different things. So each keyword is converted into a token, and the code duplication detection mechanism just detects if tokens are identical. And for example, identifiers are just considered a single type of token, so file exist and file exist one would be the same token. So it will detect, that will be smart enough to work. So the same, if you have, for example, returns log instead of logical, then it will also be detected as code duplication because it's smart enough to understand abbreviated keywords. It will also remove comments. Blank lines are not considered. It's much more than just detecting the lines of code by themselves. So here we can also, I would like to show you, I will get there. Let me. Sure.
So I do all my Java build with Ant.
Yes.
And in that Java build, I have an old version of Ant right now. And I have part of my project, I started to try to upgrade to a later version of Ant.
Mm-hmm.
And it looks like SonarQube only uses 1.7.1 or better for Ant.
Technically, you will be able to use the command line scanner, so that way Ant won't be a problem in your case. Definitely not. So the biggest requirement is to use Java 8 at least. So if you say that you are working with older version of Ant, you might be using an older version of Java, and so the main requirement is Java 8. That might be the problem, but Ant won't be a problem. So this is here SonarLint, so code analysis directly on within Progress Developer Studio. So here, for example, whenever you save something, is it large enough? I forgot to configure that. That's too bad. Okay. Good. So rules are executed on the fly, or not really on the fly. When you save your file, all the rules will be executed on your code. So here, for example, you have just a marker next to each line where an issue has been detected. So in this one, we are something which a customer reported recently. This is a use index. You define a temp table like another one, and you say use index to say, I would like to use this, only this index coming from the parent table. But in fact, there is no index IX2 because indexes are IDX. And so you end up with a temp table which inherits all the indexes of the original temp table. So this, you can have a kind of weird behavior just because this is just a typo. You just forgot the D. You can go too fast, you forget the D, and you end up with a different index definition. So you might have unique indexes. Yes, Peter?
Just to confirm, and that compiled?
Oh yes, definitely, yes. And it's even documented in the knowledge base. They say, oh, if you don't want to inherit, how is it said? They say, just use this functionality of the ABL and you will end up with indexes defined in this way. And when I reported it to tech support, they said, oh yes, it's a feature. Are you kidding me? They ended up by acknowledging that, yes, that was an issue, so it's now in the backlog. So you fix it, save, and no more issue. So here, for example, you also can have access to unused variables. So here we have an issue, one which is unused variable. So we define a variable and we don't do anything with it. And the second issue is Yes, I forgot to specify the no undo first. So let's say I will add no undo, I save, and now there is only one issue, unused variable. So let's say I will do something, I will assign something to the variable, but there is still an issue here. The engine tells you that, variable is being assigned, however, you don't read it. You don't do anything with the variable, so there is probably something wrong there. And here you can just display the content, and no more issue. You assign something to the variable, and you do something with the variable. So the parser says, okay, it's probably okay. You are doing something with a variable. Here this is a rule for an xref rule where we keep track of method usage. So here we just keep track of, and this is available here. Where is my documentation? It should be there. So I just detect any call to the HTTP client execute method. So whenever you execute one method, that will be detected. For example, you can use that in order to prevent anybody from using deprecated method. Say, oh, this method shouldn't be used anymore. So I just browse through the xref and I report any usage of it. So that there is currently no other way to really deprecate things. So this can be one usage for xref rules, just detect where something is being used. Yes, Peter?
Nice choice of sample. Can you specify if you've got an execute that takes one argument and an execute that takes two arguments? Is the engine sophisticated?
The rule is not configured this way, so the rule would just have to be improved a bit to make it work. So, but it's not currently available. So here we can also detect, for example, here, what kind of problem do we have? Abbreviated keyword, and here some hood index, and also I forgot to specify lock information, either no lock or exclusive lock, so I will end up with a shared lock, which is also a bad idea. And here we do have a hood index on the table, and we'll also get the information of the index which is being used when you execute the query. So this is only available for static queries. That doesn't work for dynamic queries. I have to be clear about that. The parser does static code analysis. It's not able to deal with completely dynamic code. And a last example. For example, here you have a procedure and you have another variable here, which you name XX, exactly the same one as this one here. So in fact, you just hide the variable XX, which is coming from the main scope, and you end up with you can have some weird behavior just because you expected the value to come from the main block instead of this internal procedure. So here the parser just says, you're just hiding the variable definition, which is at line number 22. So, and on top of that, you don't use the variable. The procedure is empty. So this is exactly what can be detected by the parser. You have immediate feedback directly when you develop. You don't have to wait until the build is being triggered and the report available in SonarQube. Cameron, you had a question.
Can you show how easy it is or how difficult it is to modify rules? Are rules in some different syntax or the JSON syntax? How are the...
So it will be, I don't know exactly what time is it, how much time is remaining?
Like an hour.
3 minutes, okay. So that will be way too long to show you how to do that. However, what I can tell you, so rules can have to be developed in Java. So everything is written in Java. If you want to develop custom rules, you just have to do some Java implementation. There is a template project which is available on GitHub. You clone it, and there is a sample rule which is already available. Out of the box, it will report an issue at the first line number of any source code. But then you have everything you need to report issues. So you will have access to the parse tree. You have access to the xref. You have access to the entire set of objects which have been read during the analysis. So classes, method, parameter, every type, enums, and so on. You have access to everything. So what you have to do is to write some Java code to detect some specific pattern in the parse tree and report it. There is a statement to report an issue. You just give the node where you want to report the issue, and that will be reported directly at the right line number. If it's in an include file, that will be reported there, and so on. So Java code, everything's Java. And I wanted to add something, can't remember it. So that was for this presentation. Do you have any question at this stage? Yes?
Can you get any metrics about who have been fixing your code? So if someone does refactoring.
So I think this information is available in SonarQube. It's not it's not visible directly from the web UI, but I've seen a project, an open source project, which does a connection to the SonarQube backend in order to display and to gamify the process of fixing issues onto your code base. And so by just detecting what has been fixed and generating some metrics. So I'm sure the information is available in SonarQube because they were able to do that, but it's an external product. And so this is really gamification and in order to give an incentive to developers to fix issues. Yes?
You have a quick demo of the code coverage?
Meaning a demo for I've shown what is displayed directly within the.
You may not have something that would be that quick, but I'm told we have an hour. I don't know.
No, we don't, because there is a session right here. This guy is coming, he's expecting me to leave. But I know him. His session is not interesting. So, if we want, yes, I've shown that, and this is for exactly what is available here. This is a red mark or a green mark next to each line, and you know if this has been executed or not executed. So you were sleeping at some point. Yeah, I'm sorry.
And they say French people are so rude, and we don't know why.
Tell the truth.
Any other question? Yep.
It's something I have.
Okay. Thanks a lot.